Hello, everyone. I'm Rodrigo, and I will be here with you for the next 45 minutes or so, demonstrating a little bit of what APL code looks like and how to reason about APL code. And so the purpose of the presentation is mostly to be a demonstration of things, so it's not a tutorial. I do know that the majority of the audience is composed with beginners, so I will be explaining the things I'm doing, but don't be worried if you don't understand everything 100%, because that's not the point. The point is just that you understand the main characteristics that make APL such an unusual language when compared with the mainstream languages that we see nowadays. And not only unusual, but really, really interesting. And I do work for Dialog, but my interest in APL appeared way before I was hired. So this is impartial in the sense that it's not because Dialog pays my bills that I really like APL. No, Dialog pays my bills because I really like APL. And so without further ado, let's start. I thought that instead of just enumerating these cool APL features, I thought it would be much more interesting if we actually built something together. And so that's what we will be doing. But just before I do that, let me share my interpreter session. So please complain in the Q&A if you cannot see my interpreter, but you should be able to see it. Let me just show you a little bit of the very basics that we are going to need. So the building blocks we will be using to actually complete the task that I will introduce in a second. So APL has two main types of things we will be using. And those are functions. So 3 times 4 is 12. And 3 times 4 times 2 is 24. So these are functions, and they can appear in between their arguments, but they can also appear to the left of their arguments. So this symbol right here, it will floor the number. So this is rounding my number down. So these are functions. Again, they can appear on the left or in between my arguments. And then there's a really nice thing that APL provides, which is a series of operators, which are symbols that take a function and modify it in some way. So this by itself will be multiplying my numbers, but if I add the operator here, this /, I can type my numbers to the right, and then this times will be, think of it as inserting these times in the middle of these numbers. And so this is going to be really, really helpful in using my functions with some other meaning, some more powerful meaning. And I didn't say so, but please do feel free to use the Q&A. I will be trying to keep an eye out for that, but usually I can only do one thing at a time. So if I'm writing code, probably I'll miss your question. So in the end, there will be some time for more Q&A. So these are the two main building blocks. There's the functions and there's the operators. And then another thing to look out for is that, and this usually surprises beginners, take a moment and try to predict what the answer will be when I press enter. If you're used to mathematics, then you would probably expect this result. So 10 minus 0 is 10, 10 minus 10 is 0. But actually, APL evaluates this to 20, because it's not strictly true, but think of it as APL evaluating from right to left. So 0 minus 10 evaluates to minus 10, and then 10 minus 10 gives you 20. So why does this matter? Well, first, because you're probably going to be surprised by this the first time you counter it, and then because this matters when you write several functions chained together. So we saw this is the floor of 2.3, it's going to give you 2, and then we do 2 times that. So this whole expression evaluates to 4. Okay, this is the very basics of how APL functions. So now let me show you what we will be doing together. So the text I picked is a fairly simple thing to explain. So let me go ahead and write some text because we will be needing some text. So to APL or not to APL, that is the question. And then there's a colon here, whether it is nobler in the mind to suffer the slings and arrows of the outrageous fortune. And then this goes on. This is an excerpt from a play by Shakespeare. And this is some text. And you noticed I was transcribing as I was typing, and I was doing it really slowly because I really didn't want to mess up the play. So I was trying not to type any typos. And as I was typing, when I reached the end of the page, the text editor went ahead and changed the line. So it wrapped the text so I could keep on typing without leaving the right margin of the page. And what happened was the text was aligned on the left, and this looks nice. But on the right, this is all jacked because lines have different numbers of words and words have different lengths. And I can make this a little bit neater if I go ahead and press that button over there that justifies my text. And now I can see the text is left aligned and right aligned. And what happened was the editor made these spaces in between the words expand just a little bit so that everything ended up with the same width. And this is what we will be doing. We will be writing some code that takes some text that's jagged on the right and then justifies it. So let me go back to my interpreter. And let's insert this text in my interpreter. So in order to define variables, you just type the name of the variable and you use this left arrow. And then to type what you would usually refer to as strings in other languages, you type in an apostrophe and then you start writing to APL or not to APL, that is. Now this is the first line, so let me go ahead and close this. And this is my character vector, so a sequence of characters. And then just please bear with me as I type the remaining lines. So the problem here, this is a double apostrophe in order to encode the actual apostrophe that's in there. So this is 2, and now I'm going to shut up because I'll type faster if I'm not speaking, okay? Okay, so thank you for bearing with me. That's that. I just typed the remaining of the sentences, and then I pressed enter to define my variable. Now, if I type it again, I can see that I have the text in here, and there's these little boxes around my text, these nice boxes that help me understand the structure of my variable. And we can see we have the lines we will be working with inside these boxes. But actually, what we want to work with, even though we want to work with the text, we don't want to work with it like this. We want to work with it in a way that, or in a format that resembles more what we have in our text editor. So let's go ahead and take those lines and stack them up together so that we have something that looks like this. And now this is a text matrix, and it's not very easy to understand just by looking at it. So we can actually ask APL, will you please tell me the shape of this thing? And you can see here 530. This means there's 5 rows in this matrix and then 30 columns, which corresponds to the longest line. And another thing that's not obvious is that APL padded these locations over here. These were padded with extra spaces so that everything could fit nicely in this 5 by 30 rectangle. And the easiest way to see this is to say, well, APL, will you please insert this nice box character at the positions where a space is equal to my elements? And then this I just described, will you please do it on my text matrix? And you can see here there's these trailing spaces. And so we want to justify some text, okay? We will work with this type of data because this is the easiest way to work with the data for our purpose. And now what we want to do is look at these trailing spaces and spread them out in between the spaces that are actually relevant for the text. So for example, there's 4 extra spaces in here, so I will be removing those and adding them in these locations, and I need to distribute them as evenly as possible. So I deleted 4, I just added 1 in each space, there's still 1 missing, so I will be adding 1 more over here, and then we will do similar things for the other lines. Okay, so this is the idea. Remove the spaces from the end and insert them in the middle of the text. So let's do it. Let's take our text matrix and redefine it to be the matrix, because that's just easier to work with. Okay, and now let's create another matrix with numbers instead of characters. And those numbers, that's our end goal, those numbers should tell you how many copies of each character you want to keep. So this is a t, this t over here, we want to keep it in our justified text. So this t should correspond to a 1, because there's 1 t I want to keep. These trailing spaces, these should get a 0 because I want to remove them. And these spaces in the middle, we want them to be either 1 or a number greater than 1 to expand, to make up for the space that is going to be removed from here. So this is what we want to build. And the first thing we want to do is to find a Boolean matrix that tells me what characters I want to keep. So let me type that and then walk you through it. So let me negate the reverse of this funny thing over here of our spaces. So what the hell is going on here? So I started out by asking APL where in my text I have spaces, and I produced this Boolean matrix. Notice there's 0, 0 that corresponds to the 2, and then a 1 for this space, for example. And then in the bottom right corner, there's plenty of 1s that correspond to these trailing spaces. So this is that. Get me the spaces, please. Then I use this primitive over here that reverses things. So the reverse of 1 to 3 is 3 to 1. And the reverse of a matrix, well, it's the matrix reversed. So the trailing ones are now leading ones. And then I'm using a really interesting operator to keep these leading ones, because the leading ones correspond to the trailing spaces that I want to remove. And so what is this operator doing? Well, we've seen 1 plus 2 plus 3, this is 6, right? But I can type it with this reduce operator that we can think of as inserting these pluses in the middle of these numbers. But I can actually ask APL to give me the intermediate results. And this is a scan. So this is 1, then 1 plus 2 is 3, and then 1 plus 2 plus 3 is 6. But instead of using the plus, I'm using this function over here, which is just a Boolean AND. So 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, and I think you can guess that 0 and 0 is 0. So if I do this, if I take my ANDs and I reduce it over a Boolean vector, this can be read as are all the elements on the right 1. So that gives me 1, and then if I have a 0 in there, it gives me 0, because there's 1 that's set to false. And if I use my scan, what I get is, I get 1s that correspond to the leading ones, and then everything else becomes a 0. So if I apply that to my, reversed matrix of spaces, then I'm able to mask, I'm able to find a mask that gives me the trailing spaces, which are just in the front right now, and everything else becomes a 0. and then I reverse it once more, and I get a mask for the trailing zeros. But I don't want the trailing zeros, I want the things I want to keep, and so I negate it. And now there's ones everywhere, except for the trailing spaces. And then I save that inside keep. These are the characters I want to keep. What now? Well, now I want to figure out the positions of the spaces that are inside the text, so these ones, that will be receiving some extra spaces. So how do I find these? Well, it's easy. I can ask once more where the spaces are, and then I can do that and say, well, APL, can you please give me the positions that I want to keep and that are spaces inside my text? And now notice there's a 1 corresponding to the first space, but these trailing spaces were masked out because those I don't want to keep. And so this gives me the inner spaces that I want to expand. Okay? So far so good, I hope. Now what do I want to do? I want to figure out how many trailing spaces there are, because I really need to be able to distribute them. So I need to know how many there are in the end, how many there are in the middle, and then do some basic maths to figure out how many spaces I'm going to hand out to each of the inner spaces. So to find out the number of trailing spaces, the thing you can do is you can take a look at the matrix of the vectors that you do not want to keep, because these have trailing ones. And then you can just ask APL to sum along the rows. And in order to sum along the rows, you can just use our plus reduce that we have seen. Think of it as inserting the pluses in the middle of each row. So the first row has no ones, so that sum gives you 0. This one has 4 ones, so that gives you 4, etc. And these are the number of trailing spaces. Now we need to do a similar thing for the number of inner spaces. So it's just a plus reduce over our inner matrix. And now what do we need to do? We need to figure out how many of these, so how many of the trailing, let me type it in here. So these are the ones that should be removed and split evenly among these inner spaces. So in the first row, there's no extra spaces, so I have to do nothing. In the second row, there's 4 extra spaces. So I need to add 1 to each of the 3 middle spaces, and then I will be left with 1 space that I should insert somewhere, and then etc., etc. And then in the last row, there's plenty of space that will go into a single inner space. So how do I figure out how many spaces each position gets? Well, I can just do, this is what I have. Can you please divide the trailing spaces by the number of spaces I have? And this gives me the number of spaces you need to add, but then I can't add a third of a space. So I can ask for the floor of these numbers. So these are the amounts I can give to per row to each space without a problem. So this one over here tells me that in the second row, every single inner space can get an extra 1. So I can do this, but then there's 1 left, and that's because 4 doesn't divide evenly into 3. So we need to take that into account, right? So these give you the numbers or the amounts you can add for sure. So these we can add without a problem. We can add them later. Now we just need to figure out how to distribute the remaining ones. All right, and how many are there left? Well, it's going to be the remainder of this number divided by that one. And in order to compute the remainder, what you need to do is you type in, well, this is embarrassing. Is this the order? No, it's not. Okay, sorry for that. So 5 divided by 2 gives you 2.5, but this is 5 modulo 2. And so what I'm doing here is taking the number of trailing spaces and then doing that modulo the number of spaces I have. And these give me the quantities that I have to distribute as evenly as possible, but I cannot do that for every single space. So I need to figure out which spaces will be receiving an extra space. And how do I do that? Well, this is where things get really, really interesting. So this is our matrix that tells you the positions of the inner spaces. Now let's look at the second row. And let's look at that. This row over here, the first space, the first position should get an extra space. It's just the first because this is 1. For the third row over here, there's 2 spaces or 2 positions that should receive an extra space. It's the first 2, and so on and so forth. So what we want to do is take these rows, and instead of having a single 1 in each position, we want to enumerate our inner spaces. And we can do that in a clever way. We can take the inner and we can do a plus scan. So this gives me running sums. So 0, 0, these give you just 0. Then you find a 1, so 0 plus 1 gives you 1. Then there's a bunch of zeros, so my running total stays the same. Then I find another 1, and so my running total increases, and so on and so forth. But then you can mask these out by multiplying with our inner matrix, and now I have my inner spaces, but instead of a 1, I have their position. Okay, and what do I want to do? I want to figure out which of these should receive an extra space. And let's look at this again. So for the third row, there's a 2 over here. So in this row, the spaces that should get an extra space, so the positions that should get an extra space are these 2. So what operation is it that we want to do? We want to be able to take this row over here. So let me copy that, paste it, and then we want to compare it with these 2 over here and ask which positions in here are smaller than 2. And this gives me plenty of things I don't care about, but then I can mask out with these again. So I'll get zeros and I will get a 1 in here and a 1 in here. So let me actually show you that. So this is where's my inner? This is definitely not how we will do it. We will not be copy pasting things. This is just to show you. So this is the third row that I'm using to mask out this comparison over here, finding out which spaces will be getting an extra space. And if I run that, I get these ones that correspond to the first 2 spaces. But I want to do this for the whole matrix at once. So how do I do that? Well, I just type the whole thing. So the inner will be masking out, and then the comparison that's hidden in here, which is the inner minus then or equal to those remainders. So inner minus then or equal to the remainders, which are these. But in order to map this to each row of my inner matrix and to each number in this little vector, I'm going to use a really powerful operator. And what this says is, well, can you please take this function, apply it to the vectors from the left and the numbers from the right? Let me delete that mask and show you what it looks like. So this is comparing. Yeah, this is not necessarily obvious what's going on, but it's comparing the numbers in here. So spaces, trail. It's comparing these numbers with the numbers in this matrix, which is the inner. And it's doing so row by row. So it's taking the 0 and comparing with this row, it's taking the 1 and comparing with this row, and etc. And then if you take this and you mask it out again, then you find the spaces that are the first ones that correspond to the positions that will add, that will get extra spaces. Except I'm doing, am I doing something wrong? Thankfully, I have something to help me. Yeah, I'm doing something wrong, which is I need to have the enumeration of my spaces. So that's why it looked weird. So sorry for that. Let's take a step back. I'm enumerating my inner spaces, and then I'm masking them out. And then you can look at this like that. Then I'm comparing with the counts that I have to spare. And then I'm masking out again. So these are the spaces that get some extra. These are the positions that get some extra spaces, but this is redundant, so I can remove it from there. And this is what I get. So this is the matrix that tells me which positions get some extra spaces. And now we basically have the matrix we wanted to build. So if I had the matrix that tells me the characters I want to keep, the matrix that tells me how many characters, how many spaces I can add in each inner position. And if I add those extra spaces, then I get a mismatch. What am I doing wrong? This is definitely not what I wanted. Oh, okay. I know what's wrong. Sorry for that. I tested this like 10 times, but of course, going live, this would be a problem. So these are the amounts of spaces I want to add in the middle, but I have to distribute them over the actual positions I have. So I have to do something similar to this over here, because what I want is for these ones over here to, instead of just saying, well, I want this to increase, I want these ones to say by how much it increases. For example, this 9 means this space over here should expand by a factor of 9. And the way I do that is by taking this inner matrix and by multiplying it with these numbers, except this is a matrix and this is a vector. So once again, I have to use this rank operator to map things nicely. And this is what I wanted to store in there. So this position will get 9 spaces. And now I can add my 3 matrices together. And this tells me exactly how many counts of each character I want. The first line is the longest line, so I do nothing in there. This line over here, this space is going to get replicated 3 times, this one just 2 times, etc., etc. And now how do I do this? How do I use this mask to replicate some characters in my final matrix, or in my text matrix, sorry? Well, I can use this symbol over here that we've seen used as an operator. We can use it also as a function. Notice if I type in 1, 1, 0, and then 1, 2, 3, what this does is give me the first element 1 time, the second element 1 time, and the third element 0 times. So I'm essentially masking out some numbers, but I can also give it a number larger than 1, and I get multiple copies. So this is what I want to use. I want to use this replicate function. But unfortunately, I cannot use it like this. So I cannot do the text and then I cannot take my interesting matrix and then use it to replicate my text. I cannot do this like that. So first I need to flatten the text and I need to flatten the matrix. And this looks like that. It's the running text. And you can see some of these spaces are already longer. And then I need to restore the original shape. And remember that we use this symbol over here to ask for the shape. we can also use this to change the shape. So row of text is the original shape. So what I say is, well, can you please take the original shape of text and use it to reshape this flattened version? And I can copy that like a good programmer. And there you have it. You have the text that is justified. And yeah, sorry, something going on in the chat, but I definitely cannot address it while I'm coding, so let's just wait a little bit. So this is the justified text. Okay. I hope it made some sense. What's interesting in here is that we worked with the whole text at once. And this was just 5 lines of text I wrote, but I actually have on me a text version of, where is it? 20,000 Leagues Under the Sea, which I downloaded from the Gutenberg project. And so this is the text file. It's really long. And I also, of course, I cheated a little bit. So I prepared something beforehand. So this over here is the code we just wrote. Okay, and I inserted it in a slightly larger function, which is a function that justifies a long piece of text. And the only thing that is going on in here is me writing really verbose code to ignore lines that do not need to be justified. So rest assured, this is not some black magic and I'm not cheating. This is our code. I can ask APL to load in the contents of that file. So I can take, no, this is just me using a function to read in the file. And I can ask for the shape of these contents. And these are the 12,486 lines in my file. And if I stack them up again, now I get a matrix. And I can justify this matrix. So I can justify the contents. And then I can say, well, let's look at the first 30 lines. And now this is really large. And there you have it. 20,000 Leagues Under the Sea by Jules Verne. And there's the text, right, justified. And notice there's how many? Almost, no, well, 12,000 lines. And I just justified everything at once and it ran almost instantly. So this is, yeah, it's instantly in my computer. So this is amazing. The power of working with matrices and larger arrays and high dimensional arrays at once. In another programming language, I like Python a lot. In Python, I would have to loop over all of the lines to figure out the maximum length. I would have to calculate all these things I've done line by line. And that's, well, after playing with APL, that just becomes really boring. So that's, after a couple of hiccups, that's what I wanted to show you. So I will be answering any easy questions that pop up in the chat. And if the questions turn out to be really hard, I'll just ask for help because I'm definitely not an experienced APL programmer. So thank you.
Thanks, Rodrigo. I think you do have a couple of questions that have been partially answered in the chat thing, but it might be good to give audible answers on this video for the sake of the recording. And I don't know if, are you able to see the Q&A panel
the
right
answer one.
So I would start from Ben Kwan asks, what does masking mean?
Okay.
You've referred to masking quite a lot in this.
Yeah, sure. So thank you for the question. We are talking about what masking means. So what does masking mean? What I mean by masking is, is using vectors or arrays of zeros and ones to extract useful information from an agglomerate of larger bits of information. So what do I mean by that? Let's look at the inner one. Yeah. So let's look at the first row of this. This is what I want to work with. There's a vector that's like that. And what I want, let's say I want to, instead of have ones in here, I want to enumerate these positions. And the way we did it was, well, first we computed a running sum over this. So this is summing along the vector and inserting the partial results. And why is this relevant? Well, because this bumps the value every time we find a 1. So this one over here, this gives me a 2. This one over here gives me a 3, so on and so forth. But I don't want all of this. I just wanted to enumerate the original spaces. So what I can do is use my Boolean vector, so my vector of zeros and ones, to remove, with just a little bit of really simple maths, to remove all of these numbers that I do not care about. And how do I do that? Well, 0 times anything gives me 0. And that's definitely not a surprise. So what I can do is take this v and multiply it with my running sum. Not divide, multiply. And what this does is, where there's ones, 1 times the number stays that number, but where there's zeros, 0 times the number makes that number go away. And so I've essentially masked out all of these running results that I do not care about, because I only wanted to enumerate these values over here. That's essentially what I meant by masking, just extracting the really useful bits of information and ignoring everything else. Okay, I thought that helped you understand it.
It more or less makes sense. Can you show an example also masking like a character vector using replicate? So just do like 1, 0, 1, 1.
Yeah.
/ something, yeah.
So if I wanted, say, I don't know, for some reason I do not like the A and the O, which are vowels in my native language. So what I can do is I can insert a 1 for each consonant, and then this is an A, I want it to go away, and then I like the L, I do not like the O, and then I like the G. And so I'm using replicate to mask out these vowels, because what I'm saying is, can you please give me 0 copies of each vowel and 1 copy of all the other letters? And so if I press enter on that, that's what happens.
Yeah, I think there's just a couple of the many ways that Boolean data gets used to manipulate other data in APL.
Yeah, definitely.
The next ones was can you read that? I don't know if I'm...
Which one? The one by...
Randy McDonald just asks whether some expression you did can be done using the rank operator instead. You can just type that in your session to
to show it.
Demonstrate it.
So Randy asked, without the actual variables, asked if this pattern, oops, oh boy, what did I do? This pattern I just used, if I could write it as this thing. And this is using the rank operator, and Adam already answered that it can. So I will definitely believe in Adam, but we can actually test it. So add an extra, and this was the text. Sorry, that's not what I wanted. I want it in here. But the point is, this is, well, for one, I'm not an experienced APLer, and this is not for experienced APLers, so I try to use simpler things where I could. So what's the problem here? It's because I'm not parenthesizing this, because I'm being silly, is it? No, yeah, it is. Okay. So yes, you can, but I didn't do it, because just flattening everything is slightly simpler, I find. And then someone asked something, which is, what's the condition to not justify a line of text? And that's a fair question. And the only thing I did was, I said, do not justify lines that are too short, because in general, you see that shorter lines don't get justified. So this finds lines that are too short. And I also don't justify lines that have 0 or 1 words, because those don't have inner spaces if it's just blank space or a single word. So that's what I'm doing. So I'm ignoring those lines, and then this is me setting up the rest of the things so I can use the exact code we just wrote. Yeah. And what else?
Yeah, there are more unanswered questions trickling in, so up to you.
Oh yeah, I wasn't noticing. I was trying to give a expression. Yes. So Remy asked why Remy got a rank error when they typed this, and that's because I also got a rank error because I was silly and I did the wrong assignment the first time around. So what I actually wanted this to be was this thing over here. So I'm just typing it for you to copy if you need it. And the point was this expression over here gives me how many spaces go into each position of my inner matrix. So this one over here tells me that all of these positions can get an extra space. And this 9 over here tells me this position can get 9 extra spaces. And so what I needed was to convert these ones to these numbers. And I needed to pair each number with each row. And so I needed to do this using the rank operator to pair the rows of my inner matrix with the values in my vector. And that gives me this matrix. For example, there's a 9 in here. Okay, then someone I think was correcting my English, which is fine. Sometimes I do mistakes, so I apologize for that. I hope I was understood throughout my explanation. And then someone asks, if you'd like to offer this utility function as a library or module, how would you do it in APL? And one of the great things about APL is that the ecosystem is really evolving right now. And so it's actually a great time to join. There's something that someone has been working on, and that's regarding sharing code as modules and whatnot. I don't think I'm in a position to say what's the best way to do it, but you can do something as simple as create a text file like I have it in here, it's in my file system, and I can just send it to you, or you can use one of these newer tools or publish it to GitHub maybe, and then people can just download your GitHub repo, or use these new tools that are being developed right now. I think Tatan is the name of something we will probably be seeing a lot. And then someone asks something I'm definitely not capable of answering decently, which is you can either mask by multiplying things or by using this replicate function, and which one is better? And I guess it really depends on the thing you're doing. So with matrices, I cannot use this as is. I need to multiply or use my AND function, but you can always test things in your interpreter with this command over here. You can type 2 expressions here, 4 plus 4 plus 4, or maybe 3 times 4, and see which one is faster. For example, if what you care about is time, and then it takes a little bit to compare the two, and then it gives you, well, the comparison results. And you can see here, multiplying was significantly faster than summing. So this is a criteria you could use to decide which one is better.
I think the other thing is that replicate or compress with Booleans, you are returning a new array with just those elements you've selected, ignoring the ones that you're masking out. Whereas when you've done it with multiply, A only works with numbers, and B, you wanted to keep the shape that you originally had, you just wanted to sort of turn off some of the values. So they're kind of different techniques for different purposes as well.
Yeah, definitely a very valid point. So V over the running sum of V just gives me the numbers, but V times the running sum of V keeps the original shape. It just ignored some of the numbers. Yeah.
Cool. I think that's answered most, if not all, the questions. Thank you again, Rodrigo. Thought that was cool.
Thank you very much. I'm sorry I made a mistake.
I think it's
It
good. I
had to
think it's
happen.
a pretty real experience, right? You recovered quite elegantly, I'd say. So that was,
Thank you. Thank
you
you.
know what I mean?
Yeah.
So
So thank you, everyone.
cool.